Hey, what's up guys? Welcome back to Josh Does Coding. In today's video, we are going to be continuing our AI series, and we're going to be looking at perception. We're going to be making it so that our patrolling AI can now spot the player and chase the player. So, in order for our AI to chase a player, we first need to create a player. So, if you already have your own game going, you can of course skip creating a new character and just use yours. But for the sake of the series, I will create one here. So we're just creating a new character blueprint, and I will call this BP player. And I will move this to the game folder. So when you open up your blueprint, what we'll need to do, whether this is a new blueprint or if you already have a character, we're going to need to add an AI perception stimuli source. This component is essentially what will allow our AI to see and in the future hear and other perceptions to be triggered by this player. So if you select the component and come over to the details panel, the first thing you'll want to do is auto register as source. You'll want to turn that true. And then register as source for senses. You'll want to hit add element. And you'll select AI sense sight. We'll go over the rest of these in future videos, but for now we're just going to do sight. And that is all there is to it. Your player is now good to go. I, of course, did not have a character to start this off, and many of you might not either. So I'm just going to go ahead and add a cube as a visual for the player. Of course, you're free to add in a mesh or whatever you would like to do for your player. Now, once that is done, we actually need to make it so that our player is spawning in at this player start. So we're going to go to settings, project settings. We're going to go to maps and modes. We're going to have to create a new game mode. So again, settings, maps and modes, and then default game mode. You'll see this create new blueprint. Just go ahead and hit it, and then you can select wherever you want it to go. I'll just throw it under the game folder, and I'll just call this BT or BP. I'll just say AI game mode. Of course, you're free to name this whatever you would like. Once you create your blueprint, it should automatically be assigned as your default game mode, and you can then set your default pawn class to be our new BP player. Once that's done, we can close out of the settings, and we can get started on the AI itself. And make sure you also save the game mode. So, the first thing we're going to do is come to our AI folder, our AI character, and we'll open our AI character blueprint. So, if we add a new component, we are going to add AI perception. This is the component that will add perception to our AI character. So if you select it and come over to the details panel, you'll see this senses config. We'll want to add a new element, and we'll set it to AI site config. Once you set it to your site config, you'll see a little drop down arrow appears. If we hit that, we can hit the sense drop down, and this is where we can actually adjust the values for our perception. So sight radius is how far in front of, or the distance that the AI can see. It doesn't necessarily need to be in front, but the distance that the AI can see. Now the lose sight radius is for, say your AI spotted the player, it will continue to see the player up to this distance, at which point it will lose sight of the player. So this is the distance that you can initially see the player. This is the distance at which you will lose sight of the player. Or, of course, anything else you're perceiving, not necessarily just a player. Now, the peripheral vision is the angle around the AI that it can see. So if you make it, say, 180, then the AI can see all the way around it. It will see completely behind it, completely to the side of it, completely in front of it. Whereas if you make it 45, it will see only in a 45-degree cone in front of it. And if you make it 90, basically anything straight right, straight left, and in front will be seen. So I'm just going to leave that at 90. Of course, you can make that whatever you would like for your AI. Detection by affiliation. This is basically teams. This is a bit more complex, and it actually requires some C++ implementation. We will cover this in a future video, but for now, we can just check them all. And then we're kind of just going to ignore the rest of these values for now. They aren't very important. The main thing is starts enabled, keep that true. Now we can close up this dropdown and we can come to the dominant sense. And we will set this to AI sense site. Essentially, the dominant sense takes precedence over any other sense. So if you see and hear something at the same time, you would prioritize sight since it's the dominant sense and hearing is not. Cool, so our AI is now set up to perceive the stimuli source on the player. Now, we need to know when we've perceived something. So we have a few events for that. We have on perception updated, which will give you an array of updated actors. And we have on target perception updated, which will give you the specific actor which was just updated. Now, we're going to be going with the on target perception updated because we are only worried about the player. So, what we can do is from actor, we can drag out and search is_a, and under utilities, you'll see is_a function. Now for the object class, we are going to enter our BP_player, or this will be whatever you named your blueprint. For the return value, we'll go branch. So if this is true, that means the player just got updated. So the player has either been seen or unseen. Now, from our stimulus output on this on target perception updated, we can drag out and we can break AI stimulus. Now here we'll get the age, which is how long ago this happened, the expiration age, which is how long until it goes away and no longer exists, the strength, this is, well, the strength of it. If something has a higher strength, it could be closer. We kind of set this up ourselves, which we aren't going to do in this video. I'll explain that more in a future video. We get the location. So this is the location of the stimulus. So this would be where the player was spotted in this example. This is the receiver's location. So this is where the AI is standing when it received this. We can add a tag to the stimulus, and it will be if it's successfully sensed. So if this updated for the player being seen, it would be true. And if this got called when the player lost, or the AI lost sight of the player, this will be false. All right, cool. So we're now checking if the player has been updated on this perception component. Now, if it is, we want our AI to chase the player. So what we can do is get AI controller. The controlled actor will be self. For the return value, we will get Blackboard. So this will return the Blackboard of the AI controller. And then from here, we can actually set a value as bool. So this will allow us to set a value in this Blackboard. As you can see, key name and bool value. So if the player is what we just sensed, we are going to set this value as a bool. And what we're going to do is we're actually going to drag in the successfully sensed Boolean so that we now, whenever the AI or the player updates perception on the AI, will inform our Blackboard if the player is seen or if it lost sight of the player. Now, of course, we need a key in our Blackboard to make this work. As you can see, if you compile right now, you'll get an error. So what we can do is come over to our AI folder, come over to our Blackboard, open this up, and we can create a new key. And this key will be has spotted player. So now if we copy this name, or you can just remember it, and come back to our AI character. From key name, we can drag out and make literal name. And then in here, we'll just put our new key name. And I'm just going to add a reroute for this Boolean, so it is a bit cleaner here in the blueprint. There we go. So we are now setting HasSpottedPlayer to the result of successfully sensed, which is perfect. But now we actually need to update our behavior tree depending on if the AI sees the player or not. So if we come to our behavior tree, sorry, ignore that. I was just doing this earlier off of video. So this is what we have on our current behavior tree. We have our AI constantly patrolling. So what we want to do is move patrol to the left, because remember, behavior trees are executed top to bottom, left to right. So we want the first thing to be patrol. Then to the right of this, we're going to drag out. We're going to add a new sequence, and we'll call this chase. Now, from chase, we will just want to move to. We'll want to move to the player. Now, of course, we need to be able to pass the player's location into this move to, but we'll cover that in just a second. The first thing we need to do with this HasSpottedPlayer Boolean is use it to tell this behavior tree whether or not it should patrol or chase. Because if you remember from the last video, a selector will execute the first sequence or selector below it that succeeds. So that means right now it will always go left first because it goes left to right, and patrol, well, it's always going to succeed. There's no check here to make it fail. So that's where this HasSpotted Boolean comes in. If you right click on your patrol sequence, we can add a decorator. Now a decorator is basically a condition check that will return a result, and if it's true, it will succeed. If it's false, it will fail. You can see there's a whole bunch in here, and we can actually create our own as well. But for now, we just need to select a Blackboard decorator right at the top. Now this will just let us check if a key is set to a specific value. So in Blackboard key, we will set this to HasSpottedPlayer, and we'll say if it is not set. So if the AI has not spotted the player, it will continue to patrol. Now if we come over to Chase, add decorator, add Blackboard, once again, we'll set the key to be HasSpottedPlayer, and the key query this time will be is set. So if the AI has not spotted the player, it will patrol. If the AI has spotted the player, it will chase the player. Now, like I mentioned before, we need to get the player location for this. Now, there is actually a few ways we can do this. We can create a task here that gets the player location. We could actually make our own move to node that automatically gets the player location built into it. But for now, we're going to keep it as simple as possible. And in BP AI Character, what we can do is we can actually set a vector value, and we can get the stimulus location. And this will allow us to move to the location that the AI saw the player at. Now, the issue with doing this is that this will only get updated or called when an actor is updated. So it will only get called once when the player is seen and once when it's hidden. So that's not great for a constant chase, because obviously you don't just want to move to one location. If you see the player, you want to be continuously chasing it. So what we can do is come over to our AI. We'll go to the tasks folder, and we'll create a new task. So we'll go to Blueprint class. We'll once again search BTT, and BT task blueprint base. We'll select that. We'll name this BTT for blueprint task, behavior tree task. And we'll say get chase location. Now, if we open up this task, we will once again do events on receive, events on event receive execute, and we can just do event receive execute right now. And we will say to get player character, get actor location, and then we get the player's location. Now, of course, we need to set this. So in the variables, just like last video, we're going to create a variable and we'll call this chase target location. Of course, you could call this player location, anything else you want. And we'll set this not to a vector. Remember from last video, it needs to be a Blackboard key selector. And again, you need to hit this I so that it is visible. Then we can drag this into our graph and we can set Blackboard value as vector. We will then hook up the actor location to the value. And after this, we can drag out and say finish execute. And we'll say it succeeded. Perfect. So now if we come back to our behavior tree, we can add in this newly created task, BTT get chase location. And of course, we'll do this to the left of move to because we want this to go before we try moving there. But now we need a key to set as our chase target location. So we'll come on over to our Blackboard. We'll create a new key and it will be a vector. I will call this chase target location. Now, an alternative to doing this is to just have one vector. So you could rename your patrol target location to just be move target, and you can use one vector for everything. I just prefer using multiple keys because I personally find that it is easier to debug once the session gets more complex. So we're just going to create a new vector here. Now, when we come to our behavior tree, we can set our chase target location for this BTT get chase location. And for this move to, we will pass in the chase target location. So now when we run our game, you can see the AI is going to patrol. It doesn't see the player because the player is behind the AI right now. So what we can do, of course, we can actually have logic to move a player. But if we just go ahead and move our player in front of this AI, it is going to spot the player and it is now going to move to the player. If the player tries moving away, the AI is going to chase it. Just like so. Now, there is a problem with this current logic. If we move like this and then we move like this, you would imagine it start going diagonally. Of course, it just lost sight of the player because we went too far away. Remember that lost sight value we said earlier. But if you noticed, it was going straight to the location over here instead of trying to chase it diagonally. I can set another example of this if we move it back in front of the player. So if I move our player this way and then this way, you'd imagine it go diagonally instead of going to this location, stopping, and then going to the new player location. So the reason that's happening is because it is finishing its current task. So if we look at the Blackboard, it is finishing this move to location and then getting the location and then moving to that location. We have no way to tell our behavior tree to stop moving to the last location and get the new location. And that is what we're going to cover next video. So if this video did help you out and you have your AI successfully chasing your player and losing sight of your player when you move too far away, be sure to leave a like. If this did help you out and you want to see more, be sure to subscribe so you don't miss the next video. And also leave a comment down below if you have any questions or any suggestions on how I can make these videos better. With that said, guys, have a good day and good luck with your games.